everyone. Our today's topic is number system. Actually, we are going to learn about some terms related to numbers, like what are natural numbers, whole numbers, even numbers, odd numbers, prime numbers. So we are familiar with all these terms, but this is part of your EDEXCEL O-level syllabus, IGCSE. So we are going to cover these all terms, how to define them, and which numbers come in each category. So let's start. So first one is natural numbers. Although this is not very much relevant, but still I want to address this because this is the basic part of the number system. So what are natural numbers? Natural numbers include all the numbers all the positive integers from 1 to infinity, 1 to infinity. Okay, or in simple words I can explain this as the numbers starting from 1 1 2 3 4 5, like all the counting numbers starting from 1 up to so on are actually the natural numbers. Okay, how I said that these include all the positive integers. You know about the integers. If you don't know, you can go to our channel, and the very first video explained all what are integers and what are which numbers are included in it, so you can refer to that as well. Otherwise, briefly we'll also discuss in the same video after doing some of these categories. Okay, so the numbers that are starting from 1 up to so on or up to infinity, these are called natural numbers. Okay, so the whole numbers, I'll write it as it includes all the positive integers and 0. Okay, so these are also the integers, all the positive integers, but the difference between natural numbers and whole numbers is that these whole numbers start from 0. So starting from 0, then 1 2 3 4 up to so on, these up to infinity, these are called the whole numbers. Okay, I don't need to write this, that these natural numbers and whole numbers cannot be written in decimals or fraction form. Why I'm not writing this? But actually the whole numbers and natural numbers are the whole numbers, like the whole number, not the decimal numbers. These are not included. Also 5/6, 2/4, whatever the fraction numbers, these all are not included, as these fractions and decimals are not included in integers as well. Okay, so referring to the integers in their definition actually means that these numbers does not involve any fractional part or decimal part. They are whole complete numbers. The natural number starts from 1 up to so on up to infinity, and whole number starts from 0 up to so on or up to infinity. Okay, now let's quickly recap what are integers. So, writing the definition, it includes or you can say, rephrase it, integers are the numbers which includes positive numbers sorry, why a comma between positive numbers? Okay, negative numbers and 0. Integers do not include do not include fractions or decimals. Okay, so now writing their example as 0, all the positive numbers 1 2 3 up to so on, and all the negative numbers, you know that the negative numbers are on the left side of 0, so -2, -3 and up to so on. Okay, so integers includes positive numbers, negative numbers and 0, and integers do not include any fractions or decimals. Okay, now let's move to the next part, even numbers. Okay, the numbers when divided by 2 leaves no remainder are called even numbers. Okay, when divided by 2 leaves no remainder are called even numbers. These are actually 2, 4, 6, 8, and also we count this 0 as an even number. Why? Because according to this definition, when we divide 0 by 2, it leaves no remainder. Okay, so 0 is also included in the even numbers. Also, this is all about the numbers, one digit numbers. How to identify a number that is a 2-digit number or a 3-digit number or a 4-digit or 5-digit number. How to identify that number as an even number? Let me explain that. So any number that is ending with these numbers will be an even number. For example, 24, 60, 98, 24. These are two-digit numbers. See, these are ending with 02468, so they are even numbers. Or any three-digit number like 420, 738, 626, 532. See, the ending number is an even number, so these are even numbers. Now I am taking like a very big number. How can you identify that as an even number? Like 225, 256,872. Or if it is ending with 2, if it is ending with 4 or 6 or 8 or A0, then it will be an even number. Okay, so to identify any number as an even number, you need to see the last digit. So I'm writing this as a note here for bigger numbers. Like 3-digit, 4-digit, or higher, or even greater, bigger numbers like 8-digit or 14-digit, you can identify an even number by looking at its last digit, at its last digit or ones place digit, or ones if it is ending with 0, 2, 4, 6, 8, it will be an even number. Okay, so it might be a very lengthy note for some people, and it might be an extra thing for some of you, but maybe some of the students are still struggling in identifying an even number, so it will be helpful for them. Okay, for bigger numbers like 3-digit, 4-digit, or even bigger numbers like 8-digit or 14-digit, you can identify an even number by looking at its last digit or ones place digit. If it is ending with 0, 2, 4, 6, 8, any one of them, it will be an even number. Okay, I am trying to just arrange this a bit. Okay, let me just change its color as well so it won't disrupt you. That's it. Now let's move on to the next topics. You can ignore, if you know this already, you can ignore this part. Okay, odd numbers. Okay, so what are odd numbers? Odd numbers are just complete opposite of even numbers. So we'll write the numbers which are not divisible by 2, or which cannot be divided by 2, or which are not exactly divisible by 2, are called odd numbers. Or if I tell you in terms of the previous definition, that the numbers when divided by 2, when they leave a remainder, it means they are odd numbers. Okay, so what are those numbers? 1, 3, 5, 7, 9, up to so on. Okay, you can also identify these odd numbers as the numbers like all the numbers that will be left after writing your even numbers will be obviously your odd numbers. Okay, like we wrote 2 4 6 8 0 2 4 6 8 10 12, so all the remaining numbers are actually the odd numbers. Okay, now to write now discuss a very important type of number system, and that is prime numbers, a very important topic or a very important definition that you need to remember, that you need to understand, that what are prime numbers. So let's write the numbers that are only divisible by two numbers that are by two numbers one and the number itself are called prime numbers. Okay, let me explain that. Any number that is only divisible by 1 and itself. Let's take an example, like we have a number 4. Compare the number 3 and 4. See, 3 is divisible by 1. 1 3 times 3 and you'll get a 0 remainder. Okay, because it is completely divisible. Okay, 1 and 3 are its two numbers with which they can be divided. But let's think about 4. 4 is divided by 1, 2 and 4. Okay, so the numbers which are only divisible by 1 and the number itself will be prime numbers, and the rest of the numbers will not be prime numbers. So among 3 and 4, 4 is not a prime number because it is not just divisible by two numbers, it is divisible by more than two numbers. So it is not a prime number. But yes, 3 is a prime number because it is only divisible by 1 and the number itself, that is 3. Okay, I am going to write one more example, one more definition of it, a very concise, easy to remember definition. But I'll write that definition. I'm leaving some space for it, and I'll write that definition after explaining you the term factors. So we'll get back to it. I'm leaving some space. for now just write some of the prime numbers. Okay, what do you think about 1? Is 1 a prime number? They say it should be divisible by 2 numbers. Okay, 1 and the number itself. But in case of 1, 1 is 1 itself and the number itself is also 1. So it doesn't have 2 numbers with which it can be divided. So it is not a prime number. But 2 will be a prime number because 2 is only divisible by 2 and 1. 3 is only divisible by 1 and the number itself 3. 4 not. 5. 5 is also a prime number because it is only divisible by 1 and the number itself. Then after we'll get 7, not 9, not 10, yes 11, yes 13, up to so on. Okay, I'm also leaving some space because I'm again coming back to the prime numbers and I'll compare it with composite numbers as well. So yes, leave some space. Okay, now move to the composite numbers. This is also not purposely, it's not a part of your syllabus, but you should know, because just like even and odd numbers, they are opposite of each other. Prime numbers and composite numbers are like opposite of each other. Okay, so composite numbers are the numbers which have more than 2, which are divisible by more than 2 numbers. Okay, that are divisible by more than 2 numbers. Are called composite numbers. For example, 4, 6, 8, 9, 10, 12, 14, 15, okay, and so on. So all the numbers that are not prime numbers, they are composite numbers, except 1. 1 is not either a prime number, it is also not a composite number, because 1 is not divisible by 2 numbers and also not more than 2 numbers. It is just divisible by 1 number, and that is the number itself. Okay, so composite numbers, just 1 is not included in prime, not included in composite. The rest of all the numbers that are not prime, they will be composite. Okay, okay, now also I'll get back to this composite after explaining the concept of factors and multiples. Okay, the factors are the numbers that divides the given number exactly. These are called its factors. Let me write it and then I'll explain it. The numbers that divides the given number exactly are called its factors. Okay, this is one definition. Or you can say the factors are mostly in pairs. Okay, not mostly, they are in pairs. The factors are in pairs when these factors are multiplied, they give you the original number. Are multiplied, you get the original or given number. Okay, this is just an extra information. Okay, now let's understand this all with the help of examples. Okay, before that, one other important thing to note, to remember, the factors are always smaller or equal to the number. Okay, factors can never be greater than the number. Sorry, I don't know, there is some problem with the writing material. Okay, no problem. Now let's get to the examples. For example, let's take an example of a number 8. Okay, so all the numbers which can divide this number exactly will be its factors. Okay, starting from 1, yes, 1 is factor of every number. Okay, because it can completely divide the number. 1, 2 can divide 8 because yes, it's an even number. Not 3 but 4, yes, 4 2 times 8, and not 6, and then 8 the number itself. Okay, I was telling you about the pair of factors. So what is the pair of factors? Okay, I'm writing 8 as separate factors. So see, this one and this one is one pair of factors, and this one and this one is one pair of factors. How? 4 2 times will give you 8, 8 1 times will give you 8. This is what I told you, that the factors are in pairs. When these pairs of factors are multiplied, you get the original number. Okay, so one thing, that the numbers that completely divide a number are its factors, and second thing is that they are in pairs. So when you multiply the pairs, you get the original number. Okay, now what are multiples? Multiples are completely the opposite of factors, but not in the way like we are doing the even odd opposites and prime and composite, in a different way. Okay, like in the factors, the numbers that divides the number exactly are called factors. In the same way, the multiple, not the same way, on the contrary, the multiples would be the numbers that you get when you multiply the number with the bigger numbers or with the normal natural numbers. If you are going to, or in other words, you can say the table of that number will be its multiples. Okay, so let's write the definition. The numbers that are obtained by multiplying a given number with one, two, three, up to so on, are called its multiples. Or you can say table of a number are its multiples. This is just for you to understand it in an easy way. So I'm taking the same number 8, okay, and what will be the multiples? 8, 8, 8 1 times is 8, 8 2 times is 16, 8 3 times is 24, 8 4 times is 32, 8 5 times is 40, and so on. So these all are the multiples. How do you get it? By multiplying it with common numbers, natural numbers, or you can say the table of 8 is called multiples. One more thing, like we wrote in this form, the definition, the factors are always smaller or equal to the number. So a multiple would always be bigger or equal to the number. The multiples are always equal or greater or equal to the number. Okay, you can rearrange this. These are the examples. Okay, now let's get back to prime numbers, okay, and write its definition in terms of factors as I told you before. So the prime numbers are the numbers that have exactly 2 factors. that have exactly 2 factors. Are called prime numbers. Okay, this is the definition in terms of factors. And composite numbers, the numbers that have more than 2 factors. Sorry, the numbers that have more than 2 factors are composite numbers. The numbers that have more than 2 factors means the more than 2 numbers that can divide them completely, more than are composite numbers. Okay, so this is one thing that we need to understand. Okay, now I will show you how these numbers are actually the factors. Like if we discuss about 2, 3, 5, 7, 11 and 13, so they will be having 1 and 2, only 2 factors, so it is a prime number. 3 is a prime number. Why? Because it is exactly have 2 factors, the number itself and 1. So 5 also have just 1 and 5 as its factor. 7 also has just 1 and 7 as its factors. 11 also have 1 and 11. So any number that just have 1 and 13 as its factor, or it is only divisible by these two, these are called prime numbers. So sorry, let's talk about composite numbers. I just want to create some space. I haven't left that much to do the same for the composite. So okay, so let's just think of some examples. For example, we have 4. So how many factors they have? See, or with how many numbers it is divisible? It is divisible by 1, it is divisible by 2, it is divisible by 4. So more than 2 factors, that is why it is a composite number. Then 6. 1, 2 and 3. Okay, then think about what is the next composite number? 8. So this is your 8. How many factors they have? It has 1 as its factor, 2 as its factor, 4 as its factor. Okay, yes, and the number itself. So in this case 6 is also a factor. In this case 8 is also a factor. So it has, see, 4 factors each, both 6 and 8. So let me write this a little here and a little here. Okay, let's see one more example. Like think of 12, because I don't have much space and it is also not needed to see every individual number and see its factors, just giving you an idea how you can understand this. 1 is its factor, it is completely divisible by 1, then 2, then 3, then 4, then 6, and then 12 itself. So see how many factors they have, and or how many numbers with which it is divisible. So this is how the composite numbers are, that have more than 2 factors or they are divisible by more than 2 numbers. Okay, now we have to discuss about the factors and multiples. Concisely giving you a short review of what are factors and multiples. Let's take an example of like a number 12, a very interesting number. With this number you can easily see the numbers which are smaller than this and with which this 12 is completely divisible are its factors. So 1, 2, 3, 4, 6 and 12, the number itself. Okay, so all the smaller numbers with which it is divisible are its factors. And if you go from 12 to higher numbers and you multiply it with 1, 2, 3, so 12, 24, 36, 48, 60 and so on, these all will be its multiples. Okay, so this was a quick review of these factors and multiples, a comparison. So if you want to understand in detail, you can refer to these definitions and these everything. And if concisely you want to remember, this is a very much concise and great way to remember what are factors and multiples. Okay, so I want to highlight this. That's it. This is all about factors and multiples and number systems and what are each numbers are. So what each numbers are, each term describes. So that's all about today. Thank you so much and Allah Hafiz.